rational expressions. Okay, simplifying rational expressions. Rational is probably a new word to us. So let's start with the definition of a rational expression. The basic definition is that it's a fraction with polynomials in the numerator and the denominator. Okay, rational, root word being ratio. Ratio should make you think fraction. Okay, ratio should make you think fraction. So rational expression is a fraction with polynomials in the numerator and denominator. Now, sometimes there won't be a polynomial in the numerator, but there must always be a polynomial in the denominator, okay? Always in the denominator, usually in the numerator, but not always, okay? Okay, so since we are dealing with fractions, we have to be careful with the denominator equaling 0, because we're not allowed to divide by 0. Dividing by 0 is a big no-no. So we've got to look out for that when we're dealing with these problems right here. So we're going to start with just simplifying these, okay? And when we simplify, we want to factor as much as we possibly can. Always looking for a GCF first, like always with factoring. Excluded values, if they ask you for the excluded values, those are what make the denominator equal 0. Excluded values are what make the denominator 0. So after we figure out what our excluded values should be, then we're going to cancel factors that show up in both the numerator and in the denominator. So let's look at example number 1 on this paper. Not bad. Okay, example number 1 on your paper right here. We're going to factor the numerator and denominator as much as possible. Okay, so with number 1 here, we start in both the numerator and the denominator with GCS. Okay, so in the numerator, what do 4 and 28, what's the biggest thing they have in common? 4, okay. Variable-wise, do those two terms have anything in common? Do they both have an A? Yes, they both have an A, so an A comes out as well. Okay, so if we take the 4A and put it in front of our parentheses, we are left with an A from the first term, plus 28 divided by 4 is 7, and we factored out the A. All right, in the denominator, what do we need to factor out of the denominator? 2, okay, and that leaves us with A plus 7. So we take out the 2, we're left with A. We take out the 2, we're left with 7. Okay, so right here at this moment, we need to figure out what could make the denominator equal 0. Okay, what could make the denominator equal 0? Anybody have any idea? Is it positive 7? If we plug in positive 7, 7 plus 7 is 14. 2 times 14 is 28. Okay, so it's not positive 7. Negative 7. Okay, negative 7 is going to make that denominator equal 0. One way to figure it out, if you don't just see it, is you take what's in the denominator after you factor and you set it equal to 0. Well, 2 doesn't equal 0, okay? But A plus 7 can. If we subtract the 7 from both sides, A equals negative 7 is going to make that equal 0. So what we're going to do, I'm just holding that over to the side right now, because after we figure out what needs to be excluded, we cancel anything that we have in common in the numerator and in the denominator. So we've got A plus 7 in the numerator and in the denominator, okay? It's being multiplied right here, so we can cancel those. Okay, we can cancel those. Then let's look at 4A over 2. Can we simplify 4 over 2? Yeah, we can simplify that, and that just leaves us with 2 in the numerator. So what do we have left? We've got a 2 and we've got an a, and that's all that we have left. So this expression simplifies down to 2a, and after that we put a comma and we say a cannot equal -7. Okay, we say a cannot equal -7. Now let me show you how you can check this, and it's super, super easy. Okay, take your calculator, plug the original problem into your y1, but be careful. You must put parentheses around the entire numerator. So parentheses 4a squared plus 28a, close your parentheses, divided by parentheses 2x plus 14, close your parentheses. Okay, so make sure your y1 looks just like that. And then in y2, you're going to put your final answer. We got 2a, so we're going to put 2x. You don't put the excluded part. You don't put the a cannot equal. Okay, you just put the equation part, 2x. Okay, now when we go to the table, check this out. All of the y values should be exactly the same. Okay, remember when we were comparing factoring, okay, to see if our polynomial, good morning, you're in that group right there, to see if we could if we had factored the polynomial correctly, we put the polynomial in y1, we put the factored form in y2, and we looked at the table to see if they were exactly the same. We're doing the same thing here. We're trying to see, are those exactly the same? Because all we did was simplify it, okay? If all we do is simplify it, it should be exactly the same. Now check out what happens when I scroll up here to -7. In y1, I get an error, okay? That's because your function x cannot equal -7. A cannot equal -7. But in y2, I don't have an error. I have a value, okay? That's because we canceled out that factor right there. That a plus 7, we canceled it out. So what was causing us a problem doesn't cause us a problem when it comes to the 2a right there, okay? But we still have to exclude it. So that's how your excluded values will show up. There'll be errors in your y1 when you check. Okay, let's do another one. Let's look at number 2. N squared minus 4n minus 45 all over n squared plus 11n plus 30. So let's simplify this rational expression here. Okay, what do we need? Do we have any GCFs? No GCFs on this one. Okay, no GCFs on this one. So let's see here. We've got n times n gives us n squared. What are the factors of 45 that add to give us 4? 9 and 5. 9 times 5 is 45. Okay. -9 plus 5 gives us -4. That middle term right there comes from -9 plus 5. Okay, over, let's factor the bottom. We've got n times n gives us n squared. How about factors of 30 that add to give us 11? 6 and 5. Okay, these are both positive because it's positive 30 and positive 11, so those are both positive numbers. Positive 6 times positive 5 is positive 30. Positive 6 plus 5 is 11. Okay, so don't cancel just yet. We need to identify our excluded values, so we set the denominator, the pieces in the denominator, those factors in the denominator, we set them equal to 0. So we get -6 and -5. Those are our two excluded values. Now we can cancel. What do we have that's the same in the numerator and the denominator? We've got n plus 5. So we are left with n minus 9 over n plus 6. And I ran out of room, but n cannot equal -5 and -6. Now, a lot of you are probably looking at that and saying, well, Ms. Redmond, why did you not cancel those n's? Okay, after you cancel the n plus 5, you write your simplified version right there. Why can't I cancel those n's? They show up in the top and in the bottom. Okay? The difference here is it's n minus 9. It's n plus 6. Over here, we were multiplying. Okay, we were multiplying so we can cancel those entire factors. Now we've got these pluses and minuses. We cannot cancel those. Okay, we cannot cancel those. If you don't believe me, let me pick a number for n. Okay, let me just pick a random number for n. Let's say 5. Okay, 5 minus 9 over 5 plus 6. So that gives us what? Negative 4 over 11. Now, if I cancel those 5s, what would I get? Negative 9 over 6, which is negative 3 over 2. These are not equal to each other. Okay? So I just picked a number for n to prove to you that you can't cancel the n's. If I plug in 5, I could have plugged in any number. Okay? I could have plugged in any number right here. 5 minus 9 is negative 4, 5 plus 6 is 11. If I had canceled the n's, all I would have left is the negative 9 over 6, which reduces to negative 3 over 2. Those are not equal to each other. You cannot cancel those n's. Okay? So that is the final answer right here. Let's look at it in the calculator one more time because I really want you guys to, I want y'all to use this strategy. I want you to check them every single time. I want you to plug it into your calculator and check it because this is how, with multiple choice answer choices, you can figure out the answer. If you forget what to do, you can plug in the original, plug in the answer choices, and see which ones give you the same values in the table, and you can even look for your excluded values. Okay, so I'm not even going to look at the graph. I'm just going straight to the table. Okay, I'm going straight to the table here. Okay, look at the y values. The y values are the same. I've got errors at negative 5 and negative 6. That's what my excluded values were. Notice in y2, there's still an error at negative 6. That's because that problem is still there. Okay, negative 6 will still make the denominator 0. We got rid of the part that was that negative 5 was making the denominator 0. Okay, so that's what we're looking for when we check it in the calculator. All right, let's keep going. Let's look at number 3. Okay, 6r squared minus 30r over negative r squared plus 14r minus 45. All right, so in the numerator, do we have a GCF? Yes, 6r. Okay, 6r. Let's factor out a 6r. When we take a 6r out of 6r squared, we're left with an r. When we take 6r out of negative 30r, we're left with negative 5. Check it real quick. If you multiply this back out, 6r times r is 6r squared. 6r times negative 5 is negative 30r. Okay, very, very easy and simple to check right there. Now, the denominator. Negative r squared plus 14r minus 45. Do we like to factor when r squared is negative? No, we do not. So, how do we fix that problem? Okay, we can't just change it, but we can factor out a negative. Okay, we can factor out a negative, which does change all those signs. We just have to make sure that we keep that negative sign in there. Okay, so I'm just saving myself a little bit of room because I didn't give myself very much room on my paper right here. So I'm just writing it right below it, and then I'm going to factor. Got to bring the negative over. Okay, just like any other GCF, I've got to bring it over. Now I'm going to factor this expression. R times r is r squared. What did you say, Jason? Negative 9 and negative 5. Okay, negative 9 and negative 5. Negative 9 times negative 5 is positive 45. Negative 9 plus negative 5 is negative 14. Now, let me bring up something. Factoring the numerator was pretty easy, right? Because it just had a GCF. But you may look at that and kind of scratch your head for a second, trying to figure out what to factor. Keep in mind that the majority of the time with these problems, something is going to cancel. Okay? Something is going to cancel most of the time. So use this numerator as a hint. Okay, we've got r minus 5. Could r minus 5 be one of our factors? Yes, because 5 is a factor of 45. To use that as a hint, if r minus 5 is one of my factors, then 5 times 9 is 45. So then, see if r minus 9, if that works out. Okay? It's just a little strategy there to use. All right, so excluded values, what we got? R minus 9 equals 0, r minus 5 equals 0. We don't need to worry about that negative in front because negative 1 can't equal 0. So we've got positive 9 and positive 5 when we solve these for r. Let's cancel now. What do we have in common? We've got r minus 5 in the numerator and the denominator. That's all we can simplify. Now, when I write this, we don't leave a negative. If there's a negative in front here, we don't leave that in the denominator. We're going to slide that up to the numerator to go with the 6r. Because it doesn't matter whether negative 1, we're multiplying it in the numerator or the denominator, it's going to give us the same result, okay? So I want to show you that because a lot of times multiple choice answer choices on the answer key here in a minute, they're going to move that negative, okay? And r cannot equal 5 and 9. Okay? So one more time, I'm going to show you again how to check this. Okay, clear everything out. 6x squared minus 30x. Make sure there's parentheses around that expression. Divided by, parentheses in the denominator, negative x squared plus 14x minus 45. You use the very original expression. Okay, don't use anything that you've done anything to for what you plug in y1. Then in y2, we've got parentheses, negative 6x, parentheses, divided by, parentheses, x minus 9. All right, go into the table. I see they're not nice, pretty whole numbers, but I see a lot of the same. I see the exact same values. At 5, I have an error, and at 9, I have an error. So I got the correct excluded values, and all my y values were the same. So those are the same expression. Okay, let's do one more, and then I'm going to let y'all practice with this for a minute. M squared plus 3m minus 10 all over 2 minus m. Okay, so in the numerator, is there a GCF? Nope. All right, so then we jump straight to 2 sets of parentheses. M times m is m squared. What numbers are we looking at? 5 and 2, very good. Where are my signs? Positive 5, negative 2. Positive 5 minus 2 gives us positive 3. Okay, that denominator looks a little weird, doesn't it? 2 minus m. We're not used to it being in that order, so I'm going to do the same thing I did on the last problem. Right below it, I'm going to rewrite it. Okay, I'm going to put it in standard form here, but the m was negative. Okay, those two numbers don't just switch places, or those two terms don't just switch places. The m is negative, the 2 is positive. So it's negative m plus 2. We don't like the leading coefficient to be negative, so we can factor out a negative, which will change those two signs. So that's negative m minus 2. If you distribute the negative back in, you're going to get negative m plus 2. Okay? So now we need to do our excluded values. M minus 2 is equal to 0, so that means m cannot equal 2. And we can cancel the m minus 2's, but don't lose your negative right there. I highly encourage you to circle it or something so you don't lose it, because a lot of people lose it, especially if everything in the denominator cancels. So that moves to the numerator. Keep the m plus 5 in parentheses. Okay, keep the m plus 5 in parentheses because of that negative that's in front. and then m cannot equal 2. You may see it written like this. They may distribute that negative through, okay? But those are equivalent, okay? Negative m minus 5 and negative parentheses m plus 5, those are equivalent to each other. And m cannot equal 2. Now, we've seen a couple of examples here where the denominator disappears or cancels out. I didn't do any where the numerator cancels out. I probably should have, but if everything in the numerator cancels out, okay, there's probably stuff left in the denominator. It doesn't just magically move to the numerator because the numerator cancels, okay? So if everything in the numerator cancels, you need to put a 1 in the numerator in your simplified version, okay? If everything in the numerator cancels, you got to put a 1 there to kind of just hold the place of the numerator. Stuff can't move from denominator to numerator, okay, and vice versa, except for if you factor out a negative. That's the only thing that can move without having to do anything else, okay? All right, so here's what I want you to do.